morning, children. Today we will start the last chapter of our science, that is work and energy. Now, can you think of some of the activities which we perform daily? Yes, some of the activities. Some of the activities you can think of like eating, drinking, sleeping, reading, writing, watching TV, chatting with friends. All these are some of the activities which we daily perform. So, what do you think? What are these activities? All these are work. In day to day language or in day to day life, we say it as work. What work we are doing? Sitting and watching TV. Or we can say any other, some of the other work which we can think about. But watching TV, drinking, eating, talking, reading, these are work in terms of day to day life. These are not actually work in terms of science. Let us take some examples like there is a big rock on the mid of the road, and you are trying to push that rock. You are spending your lot of energy, putting all your efforts, but still you are not able to move that rock from its place. You have done lot of work. According to you, you have done lot of work. Yes, but no, you did not do any work in terms of science. Yes, this must be surprising to you that in day to day life you think you have done lot of work because you are exhausted, you have lost your energy, you're tired, but still you have done no work according to science. When your examinations come, what you do? You just sit and learn. You write, make notes, you study the points, you note down lot of important points, practice papers, lot of work you do. But this is according to you that you have done hard work, but according to science you did not do any work, or you have done slightly very little work. So this, in terms of science, what is work actually in terms of science? So scientific conception of work. Now, for an example, let us take, you are climbing the stairs from the bottom. You have to climb the terrace, and so you are climbing the stairs. Now here, when you are climbing the stairs and reaching the top, you have done lot of work in this case. Or another example, you take your science textbook, you just lift it from the table to a height, that also you are doing a lot of work. A girl pulls a trolley and trolley moves through a distance. This case also lot of work has been done. It means that in terms of science, what is work? Work, here you have seen two important things. One is force has been applied. Force has been applied on the object. On the object, force has been applied, and when force is applied, the object displaces or displacement is occurring. Means these two important things are very important when we think of work in terms of science, that is force and displacement. So if there is displacement when force is applied, only then the work is done. So now, can we define work in terms of science? We define it as, here it is marked, work is to be equal to the product of force and displacement. What is work? Work is equal to the product of force and displacement. So work is equal to, you can see here the formula, force into displacement. You need to remember this formula. So here it is written W is equal to Fs. S is written, S indicates displacement. I had told you this symbol in first chapter itself. So be careful about that proper symbol. Now work, when force is applied, there has to be displacement, only then the work is done. Now work has only magnitude, it does not have direction. This is also an important point. That is, work is a scalar quantity, it's not vector quantity. Now you can see here for force, what is the SI unit of force? SI unit of force is Newton. What is the SI unit of displacement? It is meter. So what will be the SI unit of work? It will be Newton meter. So what is this Newton meter? It is given another term, that is joule. So what is 1 joule of work? 1 joule is the amount of work when 1 Newton force is applied on an object which displaces the object by 1 meter. And 1 Newton force is applied on the object, displaces the object by 1 meter. Then 1 joule of work is said to be done on the object. Again I repeat, when 1 Newton force is applied on an object which displaces the object by 1 meter, then the work done is said to be 1 joule. Okay, so this is 1 joule of work. So you got now the definition of work, definition of unit, SI unit of work, it is joule, and your definition of 1 joule of work. Clear? Now coming to the next example. Now let us take here some activities are given. You can see here in the figure what the girl is doing. The girl is pulling the toy car towards herself. So force is applied in the direction, in a particular direction, and the direction in which the force is applied, in the same direction the car is moving. That is, if you pull, so it comes towards the girl. So this type of force is called as positive force. That is, when the displacement is in the direction of the applied force. When the displacement is in the direction of the applied force, then such work done is called as positive work. Okay, that is, if I push the table moves in the opposite side because I am pushing it. So at that time the positive work is done. If you pull like the batsman is hitting a ball, he is hitting in a particular direction, the ball is moving in that direction. So there what is happening? Positive work is done. Whereas what is negative work? Zero work. When is zero work? When the force is applied, no displacement is there. I told you an example that you are pushing a rock and you are not able to move that rock. There is no displacement in the rock. So that type is zero work. No work is done. Force has been applied, surely, but there is no displacement. So that is zero work. Now what is negative work? Negative work, take for an example, you are throwing a ball upwards in the upward direction. Okay, so what is gravitational force? You know, in gravitational force, the object is coming towards the earth. It is the force which pulls an object towards the earth. But you are raising the object when you are throwing the ball upwards. You are raising the object in the opposite direction, in the upward direction. Gravitational force is in the downward direction and you are throwing the ball in the upward direction. So displacement is opposite to the gravitational force. The displacement of the ball is in opposite to the gravitational force. So that is negative work. Here negative work is done. Okay, like lifting the book in the upward direction to a particular height. Lifting a book to a particular height, that is also work against gravity. And when we talk of work against gravity, it is negative work. So in terms, how we can say, displacement is in opposite to the direction of the force. In such kind of, in negative work, displacement is opposite to the direction of the work, then it is negative work. When displacement is in the direction of the force, sorry, what I said, first thing, positive work. Displacement is in the direction of the force applied, then it is positive work. Displacement is opposite to the direction of the force applied, then it is negative work. Clear? So you have got positive work, zero work, negative work. All these things are